These are some of my favorite math stories. In this episode, Mathematics is Sherlocked. We'll put on our Dear Stalker hat and apply some Sherlock Holmes-style deductions to solve a murder mystery. The game is afoot. Well, of course, that's a huge overstatement. We will practice some basic deductive methods on a made-up murder mystery. By the end of this episode, I hope that you will not find it an overstatement that the popularity of Sherlock and other mystery series indicates that we really do enjoy thinking mathematically. Let's see what we have on hand. The following problem is in a textbook by Susanna Epp, one that I used for years in a discrete mathematics course. The famous detective Hercule Poirot, obviously a takeoff on Agatha Christie's great detective Hercule Poirot, is called on to solve a baffling murder mystery. And he determines 6 facts. Is it possible for the detective to deduce the identity of the murderer from these facts? If so, who is the murderer? And we are to assume actually a 7th, that assume there is only one cause of death. We should take a minute to review the mathematical tools at our disposal. Most of the clues are in an if P then Q form, which we often denote P arrow Q. P implies Q. If P then Q means that whenever P occurs, Q must also occur. It is not necessarily vice versa. If I sit by the fire, then I am warm, does not mean that if I'm warm, then I'm sitting by the fire is also true, especially in the summer. A statement that is logically equivalent to if P then Q is what's called its contrapositive, if not Q, then not P, as in, if I am not warm, then I am not sitting by the fire. We denote this by tilde Q arrow tilde P. Not Q implies not P. We will use 2 more tools. If then is transitive, meaning that from if P then Q and if Q then R, we can conclude if P then R. We can string together if thens like P implies Q implies R implies S. Finally, the OR in clue B is an inclusive OR, often stated as and or. In clue B, one or both of the women might be in the dining room. As in algebra, the next thing we want to do is remove distractions by simplifying the clue statements. To that purpose, let's use the following symbols. L for Lady Hazelton is in the dining room at the time of the murder. S, Sarah was in the dining room. C, the cook was in the kitchen. B, the butler killed Lord Hazelton with strychnine. CH, the chauffeur killed Lord Hazelton. W, the wine steward killed Lord Hazelton. B, CH, and W are in red because they're identifying a murderer. So, clues B through F now look like L or S. Again, that's an inclusive OR. C implies B. If the cook was in the kitchen, then the butler killed Lord Hazelton. E is not C implies not S, and F is S implies W. The first task for us is, using clue G, there's only one cause of death, identify the murderer and identify which clue was not necessary. You might want to pause the video and see if you can solve this yourself. Here is one solution. From clues A and G, we know that the cause of death was not strychnine. Only one cause of death, and he was killed by a blow on the head with a brass candlestick. So we know not B. The contrapositive of clue C is not B implies not C. And tacking on clue E gives us not B implies not C implies not S. So not B leads us to not S. Sarah was not in the dining room, which means, in fact, that Lady Hazelton was. Then we have clue D, which says if she was in the dining room, then the chauffeur is the killer. Notice that we never use clue F. So here's a variation of that problem. Suppose we replace clues A and G with H, there is only one murderer. Use clues B through F and H to solve the case. Again, pause the video and try it. Here is the solution. We'll start with a guess. Suppose S. From clue F, we get W, a murderer. Okay. Also, the contrapositive of clue E is if S, then C. So following that with clue C gives us S implies C implies D. We're assuming S, so we have B, and that's a second killer. Since clue H rules this out, it must be the case that Sarah was not in the dining room. So not S. As in our first solution, not S and clue B gives us L, and then clue D identifies the chauffeur as the killer. One more variation. What can you conclude from clues B through F alone? We allow multiple killers and causes of death. The answer is awkward because it amounts to either not much or anything is possible. In the second problem, we ruled out both the butler and the wine steward being killers because we had assumed there was only one murderer. Without that assumption, they could have been co-conspirators. And since both L and S can be true, then the chauffeur might have been in on it too. And there's no reason to rule out Lazy Hazelton or Sarah. Well, that's a bit much. Here's something that is more definite. Use clues B through F to prove that the butler could not have done it alone. So let's look at case 1. The wine steward did not kill Lord Hazelton. So not W. Rewrite clue F as not W implies not S and string it together. Not W implies not F. Clue B implies L. Clue D implies the chauffeur did it. If the wine steward didn't do it, then the chauffeur did. So another possibility. Let's say the chauffeur did not kill Lord Hazelton. So, not CH. Rewrite clue D as not CH implies not L, and string it together. Not CH implies not L. Clue D implies S. Clue F implies W. If the chauffeur didn't do it, then the wine steward did. From these two, we have that at least one of the wine steward and the chauffeur is guilty. So the butler could not have acted alone. Now, in case 2, we could have gone from S, using the contrapositive of clue E, to C, and then with clue C to B, and convict the butler also. So if the chauffeur did not join the conspiracy, we know that the butler and the wine steward did, and possibly others. Now, if the use of cases bothers you as not being clever enough for Sherlock Holmes, let me remind you of one of his most famous sayings: "When you have eliminated the impossible, whatever remains must be the truth."